Good morning, physics fans. How we doing on this last day of March? A little dreary, a little wet outside, but you know what? It is the last day of March, and the weatherman says the weather's going to start getting a little bit better. So hopefully it will start getting warmer and warmer as we go through. Sort of like it was last weekend, where we got to enjoy some nice weather. Hope all is going well within your family. Hope everybody's staying ill-free. Still, please remember to keep your social distancing. If we can't pass the virus from person to person, it doesn't continue to live. So the more times we can eliminate that, that would be a great thing. So please keep your social distancing as you go throughout the day. Once again, I hope everything's going well with you and your family. There's a couple that still need to get the test completed. Please do complete the test. We're going to start chapter 8 today. Up till now, we've done a lot of mechanics. In regards to dealing with friction, mechanical energy, so on and so forth. Today, what we're going to do into chapter 8, we start getting into more of a thermodynamics and the fluids idea, and that will complete, a lot of this material will complete the rest of the year. We'll hit maybe some energy at the very end at the end in May. But for right now, we'll start dealing with fluids and thermodynamics and work through the ideal gas law and the idea of what happens with the ideal gas law. The other thing I'm going to do is I'm going to start assessing you a little bit in regards to the notes, just sort of like what you guys used to have, what was called an exit ticket at some of the classes that you were in, where a teacher would give you a couple questions at the very end of the class to be able to assess what you received that day. I'm going to start trying to do that also in regards to the notes that we give. You'll have a little section quiz that you'll have to do our note quiz and assessment after each set of notes that we have. It will be on Google Classroom. It will be 2 or 3 questions, maybe 4 questions on basic ideas of what we've had here. So I will start utilizing that also to be able to make sure that we're getting the material that we need to get. Today we're going to talk about fluids and states of matters. Fluids and states of matters. We have 3 states of matters. They are a solid, they are a liquid, and they are a gas. And once again, I've posted these notes online, so if you can print off the notes, that would be great. I also give you a copy of our notes at the very end. They can be a solid, they can be a liquid, or they can be a gas. So you have 3 types of states of matter which you can have. You'll be a solid form, liquid form, and a gas form. When we talk about a fluid, it's a state of matter which has the ability to flow. It is the state of matter which has an ability to flow. Okay? If I have this right here in the form that we have, this is a solid form. This will not flow. But if I talk about a liquid that's coming out of my Yeti here, which is water, that has the ability to flow up through the straw. This does not have the ability to flow up through the straw. Okay? And then also we have gas. That is a fluid also. So you have mainly 2 types of fluids. You have a liquid and you have a gas. But solids are solids. And if I'm going too fast, once again, how you slow me down is hit your pause button. I promise I will not continue to talk when you have the pause button going. And then when you catch back up, then you can hit the go button again. So how you slow me down, I will not be offended. Will not be offended if you hit the pause button on me just to shut me up. It's your opportunity to shut me up. Okay? Hit the pause button and then hit the go button when you are ready. When we talk about a volume, it's empty space that can be filled. Empty space that can be filled. It's the amount of space an object occupies. It's the amount of space that an object occupies. So you have empty space that can be filled, or the amount of space something can occupy. How much space does this occupy? That would be the volume of that. what would be the volume here? This is a quart. So this space that can be occupied is a quart. That would be the volume. So when you're talking about a volume, you're talking about the amount of space an object can occupy. Once again, a fluid, it's a state of matter that can flow, has the ability to flow. This is a liquid and a gas, because both of those have the ability to flow. We have air that goes through lines, or a gas that goes through the line. Your natural gas that heats your house. You have a pipeline that goes from the front yard, through the front yard or backyard to your house. That is a gas line, natural gas line. That is a gas that flows, okay? Or you have your water line that feeds water into your house. That's water that flows. So both of them flow through the pipes to be able to service your house. What's the difference between a liquid and a gas? Okay, both of them are fluids. Okay, both of them are fluids. What's the difference between them? Well, a liquid has a definite volume. There is a definite volume. You can measure this volume in here. Okay? You have a definite volume. A gas just assumes the volume of the container. Okay, so if this container was empty, the air in there that's in there would be the volume that you have. Okay, the liquid that you have in there is a set volume, but whatever the air is, that is, or whatever this quantity is, that is the quantity or the volume of gas. Liquids are more dense than gases are. When you have a liquid, it's more dense than you have with gases. Particles in a gas move faster than they do in a liquid. Okay, you have liquid particles that are in here. Okay, you have liquid particles that are in here. Okay, they don't move as fast as if you have the gas particles that are in, if they were in here. They tend to be a little bit more screaming memes, and they move around a lot more. Okay, liquids seem to be a little bit more sedimentary, and they don't move as fast, okay, as a gas does. And when we talk about a solid, even though it's not a fluid, these particles don't move very much at all. They just vibrate back and forth. So when you have a liquid, when you have a gas, they tend to move a little bit faster than you do if you have a liquid. Liquids are more compressible. Or I'm sorry, liquids are less compressible. Okay, they are less compressible. Where if I have this thing filled with air, I can compress this down with a cylinder, a flat cylinder. I can compress the air down a little bit more. But if I have a liquid in here and I try to compress that down, I won't be able to compress it very much. Okay, but if I have a gas in there, the gas will be more compressible. The volume of a quantity of a liquid, if you have a quantity of liquid, is the sum of the volume of each individual particle. So the quantity of the volume of the quantity of a liquid, if you look at a quantity of a liquid, and if I then look at the sum of the volume of each individual particle there, if I add them all up, that will be the particle or the volume of a liquid. The difference is the volume of a quantity of gas. The volume of a quantity of gas is mainly empty space. And that empty space, that's why a gas is more compressible, because I can squeeze the particles closer together. But if I have a liquid, I can't squeeze particles closer together because the volume, the particles are pretty much right next to each other. But if I look at the particles of air that are sitting in this room, okay, they are particles all around the room. Okay, but if I would take and sort of scrunch these walls together and keep it sealed tight, I could scrunch these walls together with the gas. But if this room was filled up with a liquid and I tried to scrunch the walls together with the liquid, I'm not going to be able to move it. Okay? But with the gas, I can be able to scrunch these walls together. And that leads to the idea of compressibility. It's the ability to make particles closer together. Trying to get the particles close together. Can I compress them? Can I push them together? Okay, when I have a liquid, I cannot compress them together very well because the particles are there. If I have a solid like this, I can't push in and push the particles together closer. Okay, I can, but it's going to be more and more difficult. But if I have a liquid, I have a tough time pushing the particles close together because the particles are right up against each other. But a gas, your particles are around. So if I take a look at liquid particles, here's your liquid particles in a container. These are all liquid particles. There's not much space in between these liquid particles. So if I try to compress them down, if I would take a plunger and try to compress these down, it's going to be tough to compress these down. But if I take a look at a gas, this is a liquid. If I take a look at a gas, now my particles are like this. So if I would take a plunger and try to push down on this plunger, I have a lot of space and a lot of gaps in between all these gas particles. So I can compress it down by just pushing down on this. My gas here would not be able to stop the particles. Over here, if I would take and try to move this down, ooh, that's awesome. If I take this plunger and try to move this down, I would get to a certain point and I can't move it any further. This plunger over here, I would be able to, I would be able to take this plunger and push these objects down to get them closer together. That's the idea of compressibility. With liquid, there's not much room to be able to push them together. With gas, there's a lot more room because the volume of a liquid is the volume of each individual, and the volume of a gas is more just empty space. And why is it easier to compress a gas more than a liquid? For a gas, the particles are not as close together or compacted together. That's why it's easier to compress a gas. Once again, if you need me to slow down, just hit your pause button. I'm trying to shorten the length of the video a little bit. When we take a look at a density, the density of the object, and these are things that now you've probably dealt with a little bit in chemistry. The density is a measure of a quantity, the quantity per given space. The measure of a quantity per a given space. So your mass density is the concentration of a matter per object. The concentration of matter per object. How we calculate the density? First off, this is the symbol. It is RHO, rho. It is a P. It's sort of a curvy P. So if you start below and come up through, that is your rho, that is your density. It's like the Philadelphia Phillies. Okay, symbol for the Philadelphia Phillies. it's your mass divided by your volume. Your mass divided by your volume. So your density is mass divided by volume, or we can also say mass is going to equal to density times volume. So once again, these are some more equations that you might want to add to your sheet. Units for density is kilograms per meter cubed. That is your kilograms per meter cubed. That's your units for density. And this here is a scalar quantity. It is a scalar quantity. So it's just a number. Okay, and both of these are both scalars. Mass and volume are both just scalars. Why is a solid more dense than a liquid and a liquid more dense than a gas? Well, your masses will be equal. Your mass of the quantity will be equal. But what happens, since the solids are more compact than liquids, and liquids are more compact than gas, the volume of the solid is smaller than the liquid, and the liquid is smaller than the gas. So this volume at the bottom is going to be smaller. So the volume of a solid will be smaller than the volume of a liquid, which gives me my same mass divided by a smaller amount, which means I'm going to be more dense. So what happens with this volume, this is your key denominator here, or the factor that determines what's happening here. When I take a look at a solid form, when I take a look at this in a solid form, and then if I would melt this, the volume of this would increase. The volume would increase, which would decrease my density. If I would melt this to a point, or take it to a point where I take it to a gas, which is going to be at a very high temperature, this then would have less or a bigger volume then at that point. So what happens here is the volumes continue to increase. The masses will be the same. The masses will be the same, but the volumes will increase as it goes from a liquid to a gas. The only time that changes is with water. Okay, water. When water goes from a liquid form to a solid form, okay, it expands. Okay, so the volume gets greater. Okay, that's the only time that we have that issue, is when we have water and ice. Water and ice, the only time that the volume changes in the reverse direction is when I go from water to ice. Water is more dense than ice is going to be. Ice isn't going to be as dense just because of the molecular makeup to that, in regards to what happens when you go from water to ice. This is the initial notes with respect to the fluids. Once again, I will put a little assessment on Google Classroom that you can just answer a few of the questions, and I'll try to do that as we start going through notes. I'm also adapting in regards to how I handle notes and working with notes, so just continue to see whenever I get some notes, you'll see an assessment in regards to what we've done in the notes for that day. And it's basically questions that you have here in the notes. That's it for today. Once again, enjoy your last day in March. Once again, stay safe, keep your social distancing. Keep your social distancing. We need to do our part in regards to making sure that we don't continue to pass the virus from person to person. So keep your social distancing out there. Stay safe. Stay out of trouble. Once again, if you find some time today, FaceTime somebody. Okay, just call them up at random, talk to them a little bit, just get a little bit of social interaction. And I know that I do that with my family members also, my mom and dad, and also my my brother and sister-in-law, and we just sort of FaceTime and be able to make some social connections there. So keep your social spacing there. Let us get back to normal as quickly as possible. We all want to do that. I miss you guys. I wish we were in class. I enjoy interacting with you within the classroom. So please just try to get this back to as normal as possible, as quickly as possible. We all need to do our part on that. Other than that, I have nothing else for you. Once again, if you have any questions, feel free to email me. I'll answer back. Continue to work on getting the homeworks in Chapter 7 homeworks in. Continue to get that work in. Other than that, I have nothing else for you. Adios. You folks have a great day. Bye-bye.